Hey there, class. It's nice to be able to teach you for a moment where you can actually see my face. This is your first attempt with a little bit of a flipped classroom, which means that I'm going to teach you the lesson that I would normally teach at school as your homework today. And you're just going to be listening and following along like you would at school. And then what will happen is this will allow us tomorrow to focus more on practicing your independent practice and give me a chance to walk around and help you and make sure you're doing things right. So I think this could be a really good strategy, and I might use this more in the future. When you're doing this, you still need to have a pencil, but if I go fast and you get a little bit lost, you can always pause and go back and rewatch a section. I'll try to keep it within 10 minutes approximately, maybe a little more or less. So it won't be long and you won't have a lot of practice, but you will be listening and following along in your book. So you should have your book right now, open to page 45, and I'm going to go ahead and present my screen so you can follow along with me. And we're going to look at lesson 4 and talk about what it is you need to know from this lesson. So we're going to skip the think for today. The think problem is a clever problem. You can try it for fun if you would like, but I'm going to focus on the skills, starting with the engage. So it first asks us, what is 56 times 3? So we can solve that hopefully pretty easily. You can watch me do it for now, and hopefully you can see that makes sense. 168, 56 times 20. Similar to multiplying by 2. In fact, it really is just multiplying by 2 and adding a 0. So I'm going to add my 0 and go straight to the 2. 2 times 6 is 12. 2 times 5 is 10, plus 1 is 11. So 1,120. All right, we got those two problems. How do you use your answers to find 56 times 23? Okay, well, after what we practiced in class today, I hope you recognize that we really did just find 56 times 23, because we did 56 times 3 and 56 times 20. And so those two answers added together would equal 56 times 23. That's the distributive property. We could do the same thing for 549 times 28. That would be like 549 times 8 and 549 times 20, and then we can add those together. On the bottom, it gives you an example, 63 times 28. And again, this is the same thing. What you're really doing is 63 times 8, and you're getting 504. Then we're moving to the 2, which is really a 20. We know that it's the same as multiplying by 2 and adding a 0. So we add our 0 first, multiply each of those digits by 2, and 1,260 is what 63 times 20 is. And then we can add those together to find our total answer. Okay, and that's the skill we're working on becoming fluent with right now in math. All right, there are a few more examples on the next page. Make sure this is visible here. 623 times 32 is the same as 623 times 2. Get that answer. 623 times 3 tens, or 30. Get that answer, add them together, and we've got our total. The check, which is something I want you to be able to do, is off to the side here. We can estimate the value of 623 times 32 by rounding each of these numbers. 623 could round to 600. 32 could round to 30. I can multiply 6 times 3 and get 18, and then just add the 3 zeros. And so I know the answer to this problem should be a little bit more than 18,000, which 19,000 something is a reasonable answer. Okay? It also points out that when I rounded both numbers down, then that means the answer is going to be greater than the actual, the answer is going to be greater, okay? The estimate is less. If I rounded both factors up, then the estimate would be greater than the actual product. All right, number 3 is the exact same thing, just a 4-digit number times a 2-digit number. Multiply 6 times 5,362, 70 times 5,362, and add them together. All right, so we really want to be clear on what we're doing and why it's working the way it is. So this kind of breaks it down. I know sometimes it feels a little harder to break each step down, but let's make sure we're clear on what's expected. Fill this in with me. So 3 times 7 is 21. 3 times 9 is 27, plus 2 is 29. So I multiplied 97 by 3 ones, and I got 291. I then am multiplying 97 times 5 tens. Since it's 50, I'm going to put my 0 first. 5 times 7 is 35. 5 times 9 is 45, plus 3 is 48. Add those together, and what do I get? 5,141 as my total answer. All right, to estimate, 97 could round to 100. 53 rounds to 50. For this one, I rounded one up and one down, so the answer should be pretty close to my estimate. I'm multiplying powers of 10 right here, so I can just do 1 times 5 and then add the 3 zeros, making it easy to get the estimate. The estimate shows that the answer 5,141 is reasonable because it was very close to 5,000. All right, hopefully you guys are following along well. This practice section in here, we're going to work on in class. Okay, so we're going to be doing some practice with 2-digit multiplication. And then if we flip to the next page, it's just more of the same. This one is practicing with 3-digit times 2-digit. And then the next page is 4-digit times 2-digit. They're all exactly the same process, right? Let's do one last one together just to make sure we're getting the hang of this. And then we're going to pause for the day. So 4 times 5 is 20. Carry the 2. 4 times 0 is 0, so it's 2. 4 times 2 is 8. 4 times 9 is 36. You guys should be writing this down with me. So 36,820 is what 9,205 multiplied by 4 ones is. Next, I'm going to multiply by 2 tens, which is really 20. So I'm going to start off by putting my 0. 2 times 5 is 10. 2 times 0 is 0, plus 1 is 1. 2 times 2 is 4. 2 times 9 is 18. Add these together to get my final answer. Since you're doing a lot of steps here, it's not hard to make a mistake somewhere, which is why it's so important to consider if your answer is reasonable or not. 9,205 rounds to about 9,000. 24, I would probably go ahead and round it to 20, but I need to recognize that I'm rounding it a long way. So the answer that I'm going to get here is going to be significantly less than my actual answer. But it should still be in the same, period. Like if I got 18,000, that's nowhere near 220,000. But if I get, I think I'm going to get 180,000, that is reasonable. It's significantly larger, but it's still a reasonable answer since I rounded both of those down a significant amount. Okay? So hopefully this is strengthening your fluency with multiplying, and we're going to focus tomorrow in class on practicing this skill, and I can help any of you who are needing some support. That ends today's lesson, and I will see you guys tomorrow.